Hi all, this is Priyadashni, working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to go into the concept autoencoders. In the previous video itself, we have learned what is an autoencoder. That is, we have some basic idea on autoencoders. Here in this video, we are going to see what are the types of autoencoders, the working principle in brief, and we are going to see the limitations of autoencoders. So as we all know, autoencoder is nothing but it is a type of neural network and it is an unsupervised machine learning technique. So when we give the pass on the input data, it reconstructs the input data itself into its original form. That is your output. So let's begin the autoencoders in deep. So we all know the autoencoders has two main components, the encoder part and the decoder part. So the input data is being passed into the encoder. Consider it as layer 1. So the encoder part, what does it does it? It minimizes or it gives then compressed information. Only the important features will be there in your compressed information or in your latent space representation, or you can also call it as bottleneck layer. And from this compressed image or from the compressed data representation, your decoder tries to reconstruct your original data as that of your original data. So here you will be having a reconstruction loss, or you can also call it as reconstruction layer. So, autoencoder is an unsupervised machine learning algorithm which is more similar to that of your principal component analysis. The objective function is the same as that of your PCA. It is a neural network. So, the neural network's target output is its input itself. So, this is about your autoencoders. Let's see in brief about the architecture of an autoencoder. So the two main components in autoencoder is the encoder part and the next one is your decoder part. The input data, that it might be an image or audio or video, it would be fed as an input to the input layer, that is your encoded architecture. The encoder architecture, what does it do is, it compresses the information. That is, only the meaningful information is alone being present in your bottleneck layer or in the second part of your autoencoder. The compressed information is then passed on to your output layer. From the output, the working principle of an output layer is that it tries to reconstruct as that of the same as the input layer. For example, consider you have 4 neurons like X1, X2, X3, X4. So this input is being passed to your encoder part. The encoder architecture takes only the meaningful information from these 4 neurons. That is why you have 2 neurons as the compressed information or in the bottleneck information. So in the decoder part, the output layer tries to reconstruct as that of the original input. So when you look into the representation itself, you can see, so the input is X1, it tries to reconstruct the same X1. So that is the working principle of an autoencoder. It tries to do the same as get the same as that of the input layer. That is the working principle of an output layer in the autoencoder. So when we take the autoencoders, this is the principle of an autoencoder. It consists of two main parts, encoder part and the decoder part. So the compressed information is also called the latent space information. Therein it consists only of the important feature, or it extracts only the important feature from the input, and then it passes that compressed information to the decoder part. Now let's see the important application of the autoencoder. So it is mainly used for dimensionality detection in anomaly detection. So when you have to visualize high dimensional data, it is very tough job. So we are going to use TSNE, which is most commonly used method when you have the dimensions which is above 32. So autoencoders here, they are used for pre-processing step to reduce the dimensionality detection. So here you can see how does the dimensionality detection for the image MNIST data set. So the limitation first application is it is used for mainly for dimensionality detection. So the next second application, the main important application is these autoencoders are mainly used for your anomaly detection. So even the anomaly detections can be used to find the credit card fraud. So autoencoders is helpful for that. Now we will see the types of autoencoders. So there are two types of autoencoders called undercomplete and overcomplete. So the difference is in undercomplete autoencoder, the input layer, for example, here the input layer is 4 neurons and the hidden layer or the bottleneck layer will consist of only 2 neurons. That is, it contains minimized number of neurons as that of input layer. So this is the type of an autoencoder which is called undercomplete, wherein if you have overcomplete autoencoders, here you can see the input layer you have only 2 layers, wherein the hidden layer consists of 4 layers. That is, it will be adding some noise to the hidden layer for reconstructing the images. So these are the different types of autoencoders.